a lot of experience in scientific visualization of the universe, a field he has been involved and worked with for more than 10 years. And during all these years, he has been working on projects funded by NASA. He has taught at the famous TED, and he's also director of, okay, listen to this, astrovisualization of production and education at the Rose Center for Earth and Space at the American Museum of Natural History, located in New York.
Wow. And last year he was involved in making the show Journey to the Stars that premiered in the newly built dome at the Hayden Planetarium. And as you all heard Anders talk about, this is very interesting for us since we'll soon have our own dome here in Norrköping, just a few hundred meters away from here. So, if he's done, we will please have a warm welcome for Carter Emmart.
Thank you very much. I'm going to just check things here to make sure all is working. I need to do a sound check. Let me just I met Anders in 2001 at SIGGRAPH in August of 2001, a month before some things happened in New York. But a year after we had opened our new planetarium. I had come from a job doing visualization of climate change work for a very specific scientist at a place called the National Center for Atmospheric Research in Boulder, Colorado. But I had grown up at the Hayden Planetarium. I'd grown up at the Museum of Natural History in New York. My father was an art director for advertising agency, so he knew how to draw very well. Passed that down to his kids, a love for drawing. His sister's a teacher. My grandfather was an architect. But I came to work for a planetarium at a museum. And the idea of the artist, Dennis Davidson, who was my boss, my good friend actually, for about a decade I'd known Dennis. I would see him at SIGGRAPH, and he told me about this project in the 90s. So they were going to tear down the old Hayden Planetarium where I'd grown up, and I thought, oh, that's a terrible idea. We're going to replace it with a new planetarium, but it's all going to be real-time data visualization of the entire cosmos, the entire universe. We're going to be able to drive through it in real time with IMAX resolution on the dome. Now this was 1995, I heard this, and I thought, oh my God, my friend has really gone crazy, because he's an artist, he's a very good painter, but he was not a technologist, he was not an engineer, and but he was a visionary. And so I would see him at SIGGRAPH, and then my boss was not renewed. He got involved in some political infighting at the National Center for Atmospheric Research, and I needed a job. So the next time I saw Dennis, he was going on, oh, we're going to tear down the theater next year and all this. And I said, are you taking interviews? He said, oh, please come to New York. We'll fly to New York and we'll do an interview. And I had just done with my boss a 3-minute IMAX movie. My boss wanted to do IMAX data visualization of climate change work. And so I came and I showed my 3-minute IMAX film. We have an IMAX movie theater in our museum in addition to the planetarium. So I got the job. And it was a scary job. We didn't have any computers. We had one little SGI computer, and it was called hydrogen. We used the periodic table for our computer names, and we've gone through all the elements now. But when we started off, we had this little hydrogen SGI, and my boss and his vision. And we did have a replacement for the old planetarium. We were rebuilding a new, and that the idea of this data visualization of the entire universe was something really huge. You had to work with astronomers with their different data sets, this astronomer has stars, or that group of astronomers, that association, that international association of astronomers has just done stars. This one has just done galaxies. This one, this whole group of international scientists just studies Mars. And our job was to try to glue all that together. And it was a tremendous effort. But it was one that a large museum would rise up to try to do as a Millennium Project at the turn of the millennium 10 years ago. So a year after that, I meet Anders. And he comes from a place called Linköping University, a place I'd never heard of. Norrköping, Sweden, a place I'd never heard of. I had heard of Uppsala, I had heard of Stockholm. My apologies. Probably like most Americans, sort of, okay, we have some idea of Sweden in our heads. And I'd grown up with some very good friends down the street from Sweden, and then they later informed me, oh, you don't know Norrköping, you don't know Linköping University, all those. But anyway, when I met Anders, he came up to me and said, I want to work with you guys because you have made the jump into visualization from a star projection of just showing what the night sky would look like with an old sort of slide projection technology to data visualization of the universe. And Anders then sent a student, Stefan Klassell, who founded the company SKIS, from the work that we did together and the needs that we had for the software to display the universe across all scales. We started off with first some engineers from Silicon Graphics that helped build some software to visualize our various data sets stretching across the universe. We worked with the National Center for Supercomputing Applications and the San Diego Supercomputer Center with experts from these two major national supercomputing facilities who had done visualization on the grand scale. And we worked with them on making our first show. But our goal to drive across the universe was something that has taken a lot of work. I have had 12 students from Linköping University, thanks to Anders. And Anders has enabled us to really change what and how we're doing work. The students from this university have all been top-notch, have all worked incredibly well with us. Andreas Wetterborg, right here, sitting here, was my student this fall. He's now my chief technical director for making the first piece, our opening show in your new dome. And it's a great honor to be here to do that. So, as you may have known, I gave a talk at TED. I was invited because some of the people from TED came to a World Science Festival event that we had. This is an event that happens in New York City at many different places, and we hosted a discussion of cosmology in our dome at the Hayden Planetarium for the World Science Festival last spring. And so some of the principal people from TED came. And there were a lot of astronomers talking about cosmology. But what caught their eye was that somebody behind the console was able to drive through the universe. And so they called me up sort of at the last minute and said, can you come give a 6-minute talk at TED? It's really hard to give a 6-minute talk. I've probably already talked for 18 minutes. So I'm going to run this back just a little bit, since we have the audio, and I'll start this piece, The Known Universe. This was a collaboration with the Rubin Museum of Art, Himalayan art. You'll see Tibet sort of in the camera view as we pull off, but this is a art museum in New York, but they were doing a comparative cosmology show, and they wanted to work with us. What you're seeing here is just a statement. This is a piece that's on YouTube. If you just request Known Universe, you'll find it. But this was the idea, and we've come sort of full circle to where this is now on YouTube. We've had 4 million views so far since December 15th when it was posted. But the dream is to go from Earth into space. And rise up. These are a series of NASA data sets that we see, but we're looking out over the Earth. We're fading up the clouds here. We pulled up through the atmosphere. This was all recorded live in the software that the students in Linköping were able to create. We've had 12 students so far. This UniView software, which is now software that is supported by the company SKIS in Stockholm, but the ability to visualize all this. The data sets for the orbits of all the satellites around the Earth, the low Earth orbiting satellites that we see. They go around the Earth every 90 minutes. And then farther out, we see an engagement of GPS satellites. And beyond that, you see a fairly strong line. You see over the Earth's equator, out about 22,000 miles, I'm sorry for miles and kilometers, of the geosynchronous ring, farther out the moon's orbit. So this ability to sort of go from almost human scale down on the surface of the Earth on out through space has been something, as I say, of a dream to be able to do. Of course, a precursor was the movie The Powers of 10. I actually have it with me, and I might show just a little bit for those of you that might be unfamiliar with it. But this ability to sort of fly anywhere. I flew this live at my corner cafe on the Lower East Side of Manhattan. I had to do many different versions until I was happy with it. But what you're seeing is a live flight. The stars are distanced from the Hipparcos star catalog. That's radios here. It shows our extent of our radio signals out into that stellar database. And then beyond that, a very small portion of the galaxy is what we actually see of stars. And then we're out into a much larger database of galaxies that have been charted so far. This work from Brent Tully, bringing a catalog of catalogs of galaxies together. And then finally, these almost butterfly wings, as it points out there, empty areas where we've yet to map. Those empty areas are essentially because the Milky Way blocks our view. So we avoid the plane of the Milky Way that we're immersed in, as you saw as we pulled out. And then finally, if you look farther out, the farthest thing we can see is the youngest thing we can see, because everything's coming to us, traveling at the speed of light. So that represents our cosmic horizon, literally in space and in time. And we've mapped that only in the last decade. We come back, the bright objects transitioning to the inner galaxies, and then the galaxies that completely surround us. We're flying back to our location, but also we're flying back to the present. The nearest star to us is we see it 4 years ago. The galaxy is about 100,000 light years across. We live halfway out. The light from the center of the galaxy takes about 25,000 years to get to us. The light we see from the center of the galaxy left when we were basically using stone tools and putting the first art on cave walls. So we come all the way back. Seen from afar, we would only see the glare of our star. Here we have to artificially dim it to actually see the orbits of the planets, to see our solar system. The outer planets, Neptune, Uranus, Saturn, Jupiter, Mars, Earth, Venus, and Mercury. The orbit of the moon, it's 250,000 miles, but you can see it's very tiny compared to where it is and where we are in space. This was difficult coming back after doing this whole flight across the universe, to come back and try to come back into the Himalayas. We come back over Southeast Asia and circle around. The Tibetan Plateau here. So this was essentially the talk I gave at TED. But it represents really a culmination of a decade's work of attempting to visualize the cosmos in a way that's understandable, from going from something that's familiar, mountains, maybe it's not familiar to you, standing in Tibet, maybe some of you have been to Nepal and seen the Himalayan mountains, but that's our piece. Brian Abbott, manager of the Digital Universe Atlas, colleague I work closely with. So, all right. Great. So what I'd like to do is actually show you some of the work that led up to that, or the facility, and where it come from. So I'll bring that up. Hopefully, let's see. Just do a slideshow. Is that one? Okay. This is the Hayden Planetarium that I grew up at. And this is a picture taken right after it was opened in 1935. I'm not that old. I'm pretty old. But what we can see here is we can see the old school buses. And this tree, by the way, is still there. It's much bigger now. But this is the footprint of the old Hayden Planetarium, a sort of Art Deco building. You can see the extent of the American Museum of Natural History around it. Facing out in this direction, or running parallel to this wall on the other side, is Central Park West. And so Central Park is in that direction. And we're looking south from 81st Street. And but inside the theater, inside the dome, was something sensational. The year that we opened, 1935, was about 10 years after the first one of these was built in Jena, Germany. And the Zeiss company made this elaborate optical beast. This was an optical mechanical slide projection system that could show you the sky and present accurately the stellar positions. And so here you see a somewhat fantastical drawing showing a crowd of thousands underneath one of these domes, but showing the skyline of New York, and the lecturer standing here with a laser, essentially, when we didn't have lasers back then. But a star pointer to point out the constellations. Now this optical beast could roll around, and it could replicate the diurnal motion that we see, the stars tracking across the sky. It could also give you the months, and then the thing could completely tip to show you the southern skies, and so on. And this was essentially the workhorse of a planetarium up until we decided to put in video projection and turn the dome into a visualization center. And so this just shows, this is me around that era. This is actually 1969. I show this picture mainly to show that I was inspired by going to the museum and seeing the dinosaurs and coming home, and my dad took this picture. But I think it goes to the heart of why I'm standing here today and talking to you all. I think it's probably why most of you are sitting in this audience, that you're interested in the subject. You want to do something creative. You want to make something new. You want to do something for the first time that's ever been done. And being inspired by the museum was a big part of my life. This is Yosemite Valley, but it's a diorama. This is in our Hall of North American Mammals. And I love to show this picture because it's not so much the coyotes, which you see. It's a coyote exhibit, really. But Perry Wilson, who painted this, he died in the 1970s, but he was a virtuoso of these backdrop paintings. Right here is the border between what is the diorama and what is the background. And so he's done this painting, and you see this puddle that's reflecting El Capitan here. Here's Half Dome over here in Yosemite Valley and the Merced River. But this reality, this beautiful painting that takes you and puts you in this place. Our job with visualization is to put you in front of the universe. Like you just saw, we just took you out there in this rectangular projection. But when you wrap that around your head at the planetarium, we are essentially taking you into, in the traditional sense, into your backyard, into the middle of Central Park. You have buildings around you, and you've got the stars up over you. It's fantastical. You're out in an open field, and that dome is just a metaphor for the infinite in the sense of when we go out and we stand in a field somewhere and you see that beautiful sky. It might as well be a big bowl over your head. It took us a long time to sort of figure out that it wasn't. It's actually larger than that. And that these dioramas trick us. They trick us in the sense that we're there. We stand in front of there's a big glass plate here, and we look into this thing, but it's to take you and put you there. In an era, in a big city, when this was built in the 1930s, people weren't traveling around the world as much as they are today on jets and things like that. It take you to other places around the world. This is a picture taken in the same location as that picture I showed you from 1935. And the place is completely rebuilt. In fact, they tore out the old dome and they put in the new. So this sphere, actually, here you see just a small shot, not enlarged, but anyway, the sphere stands on legs, the top half of which is the new Space Theater with a horizontal flooring. It's not tipped. I like the tipped idea of what's going to be here in this visualization center. It's more of a sort of, as you all are sitting here, have the dome over you. It's just more like sort of a flight simulator motif. But ours is a traditional planetarium designed by the architects with the constraint that we were going to have a modern star projector, but there was no decision on whether we were going to have visualization and projection on our dome. So this is what it looks like down below in the sphere. That's it. It's terrible, Space Theater, but you see this ramp coming out. You actually go, the idea is that you go to the Space Theater up top, you see the latest film visualizing the universe, and then you walk down into a ramp that's actually along the, what you see here, it looks like an A-frame, but you're just seeing a distortion from the lens. In a corner, this ramp walks all the way around a square walk around the glass wall, and that gives you a scale walk of the universe with various scale models comparing to the sphere. At one point, the sphere is the sun, and they have models of the planets. You walk a little farther, you're getting smaller and smaller. This is the electron cloud around a proton about the size of your fist in front of you. And then you walk into the Big Bang, and you have a recreation of the birth of the universe. This is something when I go home we're redoing, actually, starting in May. And then you walk out on a ramp of time, which you see here. And you walk from the Big Bang to current time. We've been around for about 14 billion years, so this ramp, when you take one step, you're walking typically about 150 million years. And the amount of time that humans have actually been on the planet, essentially since artwork has been created in cave walls and so forth, is about the width of a human hair at the end of the ramp. So it's kind of humbling in time and space. So that's what the facility looks like. And this is actually a shot from making a show called Sonic Vision in our modern dome. This is an Alex Gray painting come to life in the Sonic Vision show. So, great. What I'd like to do is give you a quick excerpt of the most current show that we have. But before I do that, I wanted to show what sort of goes into that first. And so, let me just, navigating back and forth between Mac and Windows is difficult. Let me get that together. Okay, here we go. this is sort of how the process starts out, how we make our shows. You've seen in the very beginning the dream come alive that we can actually fly manually through the universe, all these different data sets, and create the movie that you saw, a very quick movie, The Known Universe. But for our main venues, for our main movies that we make, and we've only made 4 of them in the last 10 years, that we craft storytelling with major themes of the cosmos through data visualization. And we've done 4 shows, as I mentioned, actually 5, I'll explain the 5th one. But the main shows, we did Passport to the Universe, that's what we opened with, which took you through the universe, similar to what you saw in the Known Universe, actually, which we can now do flying, in a cafe on a laptop. But it took a lot of work doing that on big computers 10 years ago. We bought, essentially, to do the visualization work, we had 2 large SGI multi-video pipe systems. And that's probably the reason that Anders even talked to me, was that, that we had research-grade equipment to do our shows. And that also enabled us to do our shows with research facilities, such as the National Center for Supercomputing Applications and the San Diego Supercomputer Center. Working with the SGIs, working with a large Unix system, that we were able to work closely with those facilities. But the idea has to start out essentially with some notion as we sit down and have discussions with the scientists, and they say, what's this going to look like?